Hello, and welcome to section 4 of the Automated UI Testing in Android video course. Previously, we've created the basis for UI framework and we've updated our sample test accordingly. So, our current solution is operational for trivial cases. But this time we'll take a look at more complicated cases which appear as soon as you start working with more or less complicated environment. In this section, we'll go through several quite common cases for complex pages and elements handling. Firstly, we'll take a look at platform-specific identifiers and how to deal with multiple independent platforms. Secondly, we'll work on customizing elements behavior to make custom elements compatible with standard elements. Then, we'll take a look at how to deal with compound elements containing sub-items. After that, we'll take a look at how to scroll to different elements. Then, we'll make some additional useful enhancements to our controls. And, in the end, we'll go through some additional functionality which helps us with verifications and which would be helpful in the future. In the first video, we'll take a look at platform-specific identifiers. They normally appear when we operate with same application implemented under different platforms. In this video, we'll introduce the enhancement which handles platform information. We'll create functionality supporting multiple object locators for the same element and apply changes to choose the most appropriate locator for the platform. In the end, we'll create an example which verifies object on page using platform-specific locators. We'll exercise the same test on web and Android platform to demonstrate that we can declare page objects for several independent and incompatible platforms. So, let's get started. Since we introduced the concept of platform, we need some entity which stores relevant information about it. The first step is to create the enumeration called platform. In addition to constants, it should contain private field value which should correspond to the platform or browser name from our configuration file. We should create constructor initializing this field and getValue method which returns the value of our private field. Then we can add constants which have the string value associated. In addition to browsers, we'll add more entries for Android and iOS native applications, as well as Android web. Also, we'll add an entry called any. It will be needed for filtering when we need some identifier matching all supported platforms. After that, for better convenience, we can add two methods which can define whether the current platform is Android or iOS. Next two methods verify if requested platform belongs to a specific group of platforms. For instance, native mobile applications require path to application package, while web applications use URL for the start page. We'll exercise that later in this video. And finally, we need to have a method which converts string from configuration file into platform enumeration value. Thus, we add fromString method which returns the constant matching specified input string. Now we are done with the enumeration. Next step is to update configuration object to handle the platform. Mainly, we need to add just one method which gets the browser configuration parameter and transforms it into platform enumeration which is then returned. And finally, we need to update the driver object. We'll create drivers map which sets the correspondence between platform enumeration and actual WebDriver class. Then, we'll add init method which initializes WebDriver instance by giving URL, platform and capabilities. Unlike for web applications, for mobile applications we'll use URL. So, it's mainly about calling different constructors. Once we are done with the init method, we can go further. Now it's time to add platform handling into locators and into find-by annotation in particular. Firstly, since we potentially need multiple locators, we need to make our find-by annotation repeatable. For this purpose, we have to add new annotation called find-by-list. It contains the only field values and return the array of find-by elements. Once we have it, we can update find-by annotation with additional attribute. It's repeatable annotation with the find-by-list class as the parameters. This way we define that multiple find-by annotation can be assigned to the same element which is not allowed by default. Note that this capability is available since Java 1.8 version. If you use older versions, this functionality wouldn't work. One more change to apply for find-by annotation is to add platform field which returns any by default. This way we still keep compatibility with previous behavior. Now we have to handle find by annotations from the pages. For this purpose, we need to update page factory class. What changes this time? Firstly, instead of getting single annotation, we can use get annotations by type. It will return the list of annotations of find by type. This makes things easier, as now we can get rid of get annotation field method. Now we need to get specific find by annotation matching the current platform for the list of find by. For this purpose, we'll add new static method. Let's name it getLocator for platform. It goes through array of find by elements and returns the item which platform matches the parameter we pass. If nothing matches, the null value is returned. Now we can get back to init method. We have a list of find by elements and we have method filtering this array by the platform. Let's initialize new annotation object with a find by element which contains current platform. If this object is null, we'll try again by searching for platform with the value of any. It means that if we don't find specific locator, we'll look for common locator then. Once it's done, we just initialize control object with the locator string. So, after all those changes, our page factory now handles multiple find by annotations and it can choose platform specific one. Now it's time to update our sample test pages with platform specific locators. Right now we'll take the search page. I chose booking.com application for the purpose. It's available both as website and native mobile application. Initial UI is almost similar, but what is definitely different is identifiers. Let's open Chrome browser and inspect elements. For web applications, a lot of elements have ID, name or some other attributes which are easy to use. Now, for search page class, we'll add additional find by annotations for each field we need and we'll set corresponding identifier from the web application. Additional update is the platform identifier. Since web applications usually have the same identifiers for any browser, we'll use web locators as default. It means that Android-specific locators require platform specified. After all the changes, we have updated search page, which is now supposed to be compatible with web and Android versions. Now it's time to prepare sample test. At the moment we just need to prove that we handle UI definitions depending on the platform, so we don't need to dig too much into behavior of applications. Handling different behavior of similar elements on different platforms will be covered in the next chapter. For this video, we'll create new test which verifies UI elements on booking.com landing page. Before adding new test, let's move some common functionality out of our existing sample test. We'll create test command class and copy before and after methods from our sample test, as well as we'll move our page declarations. Now we can get back to sample test and expand this class from test common. Test should work the same way. Next step is to create search page UI test class extended from test common, where the only test verifies elements' existence. We initially assume that we are on landing page and search page instance is initialized, as it's done in common class. We can run it to confirm it works for Android application. Now let's make changes to make it run for web. Firstly, let's open config properties and add 3 more entries. They are the page URL, the URL web page to open. It is needed if we run browsers. Browser. It is typically needed for web applications on mobile devices. Platform. The platform we are going to use. After that, we can go to the test command class and check setup method. Right now, we should update initialization of the driver object by calling driver init method. Also, if we work with web application, we should open the web page. That's why we add more instruction which open the web page and at the URL defined in the configuration. Finally, we open our test and add more if statement which handles landing page for Android application, while for web we simply initialize search page as it is. Don't forget to get appropriate driver binary to the browser as well as specify the path to it via system properties. Here I'm using Gecko driver. for Firefox, and here I define the property for it. Now we can run our sample test for web. It passes. Now let's switch back to Android configuration and we'll see that the same test for mobile application also works. This is it for this video. We've introduced multiple locators for page elements. Also, those locators are handling different platforms, selecting the one which corresponds to currently configured platform. And finally, we've created sample test which is runnable both for web and Android. Since those two applications use different UI type with different identifiers, the successful test run results prove that platform-specific locators enhancement works. In this video, we've just looked at the way to define similar elements with different locators for different platforms. But our elements may also behave differently on different platforms. It makes behavioral difference.